Hi there, welcome to EudretiX, where we make your high school life simple. I'm Aniket, and this is part 2 of the medium difficulty problem solving for linear functions as part of our Digital SAT Algebra practice series. So make sure you follow along, try the question yourself before looking at our solution, and let's begin. The table above gives the typical amount of energy per gram expressed in both food calories and kilojoules of the 3 macronutrients in food. If X food calories is equivalent to K kilojoules of the following, which best represents the relationship between X and K? Okay, so there are two quantities given. Let's say on the y-axis we take the K kilojoules, and on the x-axis we take X food calories. Okay, so it's a conversion between calories and kilojoules, and they're asking us the relation between the calories and kilojoules. Okay, one way to do it is to use these points and try to figure out, as you can see from the options, that this won't be having any y-intercept. The relationship will not be having any y-intercept, so that means it's simply going to be y is equal to mx, that is slope times x. So this slope quantity, that is basically the factor of multiplication, which when multiplied with the food calories gives you the number of kilojoules. So for that you can directly divide 16.7 over 4. You can simply divide this. So you will get 4 times 4 is 16, and then so 4 times 4 is 16, and then 0.70, so sorry, that would be 4.1, and 334 times 7 is 28, 4 times 20. Okay, so 4.175, so approximately 4.2x. K is equal to 4.2x. That's the relationship you get from here. Okay, another way to do this is to go via Desmos. Let's see how to do that. So on Desmos, you'll plot the points that are given. So first take the table option, then 4, 16.7, and 9 and 37.7. 9 and 37.7, because only 2 unique points are required to identify a line. Okay, now we'll do a regression. y1 tilde b0 plus b1 x1. Okay, so you see b0 is negative 0.1, b1 is 4.2. so this constant is needed. It's approximately the intercept is really small. As you can see, the intercept is literally negative 0.1, so it's a really small intercept. So that's why they approximated it to be just slope times x. So that's 4.2. b1 is equal to 4.2. You can get directly from Desmos. Okay, let's go ahead to the next one. If f of x is equal to x plus 7 and g of x is equal to 7x, what is the value of 4 times f of 2 minus g of 2? So 4 times f of 2, 4 times f of 2 would be 2 plus 7. Minus g of 2 would be 7 times 2. So this is 2 plus 7 is 9, 9 times 4 is 36, minus 7 times 2 is a 14, which is equal to 22. Option C. So this is simple and straightforward. Let's go ahead to the next one. Y is equal to 18 minus 5x. The equation above represents the speed y in feet per second of Sheila's bicycle x seconds after she applied the brakes at the end of a ride. If the equation is graphed in the xy plane, which of the following is the best interpretation of the x coordinate of the line's x-intercept in context of the problem? Okay, so let's read this again and try to decipher what they're saying. So the equation above represents the speed y in feet per second of Sheila's bicycle x seconds after she applied the brakes at the end of a ride. Okay, so the speed would be decreasing. This 18 would suggest, so we get y is equal to 18 when x is equal to 0. That is the y-intercept. This suggests that the speed, it was 18 feet per second before she started applying brakes. As soon as she starts applying brakes, with each passing second, the speed would reduce, which is what we can see from here. It would fall by a minus, by a 5 feet per second. Each second the speed would fall by 5 feet because the slope is -5. Okay. So now they're asking the best interpretation of the x coordinate of the line's x-intercept. So what would the x-intercept mean? It'll mean y is equal to 0. X-intercept means y is equal to 0. That means when does the speed become 0, or when does the bicycle fully stop? That's the x-coordinate. That's the time taken for the bicycle to fully stop. Okay. So let's look at the options. The speed of Sheila's bicycle in feet per second before Sheila applied the brake. That's the y-intercept. Option A. B. The number of feet per second the speed of Sheila's bicycle decreased each second after Sheila applied the brakes. That's the slope. The number of seconds it took for the time Sheila began applying the brakes until the bicycle came to a complete stop. That's the correct answer. Option C is correct. Okay. The number of feet Sheila's bicycle traveled from the time she began applying the brakes until the bicycle came to a complete stop. That would mean calculating the distance, and that would involve another quantity, that is acceleration, since the speed is decreasing. Okay. So as we can see, the speed is decreasing by -5 feet per second. It's decreasing. That can be taken as the deceleration or retardation. In that case, let's try to find the value for option D. This is just a detour from the usual question. So 18 minus 5x is equal to 0. That means 18 over 5 seconds. That's the time taken to stop. Okay. In 18 over 5 seconds, it's stopping. Initial velocity was 18 feet per second. Final velocity is 0 feet per second. And acceleration is -5 feet per second squared. Be very careful about the quantity, like units per second squared. So let's check. S, the third equation of motion, is equal to ut. Initial velocity, that's 0. That's time. Oh, sorry, not 0. Initial velocity is 18. 18 multiplied by 5, 18 over 5 minus half 5. T squared is 18 over 5 squared. This cancelled. 18 squared over 5. This will be common in both the terms, since this is also 18 squared over 5. So 18 squared over 5 times 1 minus half, that is half. 18 squared over 5 times half. 18 squared is 324 over 5 times 2 is a 10. 32.4 feet before coming to a complete stop. Okay, so this you can try when you're practicing. Okay, but don't do this when you're sitting for a timed test or even for a timed practice. Okay, this was just a short detour from the original question. Let's go to the next one. The function f is defined by f of x is equal to mx plus b, where m and b are constants. If f of 0 is 18 and f of 1 is 20, what is the value of m? They've simply given you 2 points, 0, 18, 1, 20. 20 minus 18 over 1 minus 0, that's 2. That is the slope. Okay. The graph above shows the distance traveled d in feet by a product on a conveyor belt m minutes after the product is placed on the belt. Which of the following equations correctly relates d and m? Okay. Looking at the graph, you can see it's passing through the origin. That means there is no y-intercept. So either option A or B. Then let's look at the slope. So there are 2 points. One is 0, 0, one is 1, 2. 0, 0, 1, 2. So 2 minus 0, which is a 2, over 1 minus 0, which is a 1. Slope is 2. D is equal to 2m. Option A. That is the correct one. Okay. This is how you can quickly figure out what is being asked. Okay. Let's go to the next one. The boiling point of water at sea level is 212 degrees Fahrenheit. For every 550 feet above sea level, the boiling point of water is lowered by about 1 degree Fahrenheit. Which of the following equations can be used to find the boiling point B of water in degrees Fahrenheit x feet above the sea level? Okay, so as we go above the sea level, the boiling point is lowered by about 1 degree Fahrenheit, and this happens for every 550 feet. Okay, at sea level it's 212. So the B boiling point would begin from 212, would go on decreasing for every 550 feet above the sea level. Okay, so let's say the water goes x feet above the sea level. To find out how many degrees Fahrenheit will the boiling point fall by, we'll divide the x with 550. Each of these, like every time whatever quotient you get, you multiply by a 1 in order to indicate the lowering, because it's lowering by 1 degree Fahrenheit for every 550 feet raise above the sea level. Okay, so let's say if x is 2000, it's like 212 minus 2000 over 550 times 1, which is 5 times 11, 40, 11 times 3 is 33, 3.6. So it gets lowered by 3.6 degrees, which is 212 minus 3.6, that is 208.4 degrees Fahrenheit, like that. So option D, it's decreasing, begins with 212, and that's how we figured out. Okay, so this is where we end our medium part 2 of the linear functions practice for Digital SAT Algebra series. In the next 2 videos, we'll be doing hard difficulty questions. You can choose to skip the easy and medium ones in case you've already done this topic, but make sure you do the hard questions. Those will be really beneficial for your actual SAT test. Okay, let's meet in the next video. Take care. Bye-bye.